Alright, in this lesson, we're going to start looking at solving quadratic functions or equations with the quadratic formula. So the reason we need this is not all quadratic equations can be solved by factoring. The quadratic formula can actually be used to solve any quadratic, and so far we've learned a few different ways to solve quadratics. We've learned how to solve by factoring and using the zero factor property. Or sometimes, like the one we're going to look at next, the quadratic equation will not factor, so you can't use that method. We've also learned completing the square. And while that will work, it doesn't take very much for completing the square to become difficult and very involved. The other way we've learned is to use the square root property. And of course, that only works in specific situations when we have a squared term or expression equal to a constant. So the quadratic formula is something that will work in any instance, and you don't have to worry about these different problems coming up. So if you look at the example here, up until this lesson, if I asked you to solve this quadratic, then we could try to factor it out. And we know we'd have to have x and x. The only factors that can give me -1 are a -1 and a +1. But you see, if I check those middle two terms, I'm going to get -1x plus 1x does not give me a 1x in the middle. So it won't solve by factoring. If I tried to complete the square, we did this back in the first lesson for this chapter. We would have to move the 1 to the right hand side. And then you remember we have to take half of the number that's in front of the linear term. And then we square that. And that's what I would add here and here. And I think you can see the complication. It's not that it can't be done, but if you're like me, you're not going to want to deal with those fractions if you don't have to. So the quadratic formula is something that we can do in these instances. So given a quadratic equation in standard form, which we've looked at before, is ax squared plus bx plus c equals 0, then using the quadratic formula, we get the solutions. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So, of course, this is two solutions. One of them is -b plus the root of that expression, and the other is -b minus. Alright, so let's look at an example of one. This first one says solve the equation using the quadratic formula. So when we're going to use this method, we want to make sure that our equation is in that standard form. And this is in ax squared plus bx plus c equals 0 form. So as long as that's true, we're going to determine a, b, and c. So a, of course, is the number in front of the squared term, which is 3. B is the number in front of the linear term, which is -4. And c is our constant, which is -2. And then all we're going to do is substitute these values that we found for A, B, and C into the quadratic formula and simplify. All right, so let's see what that looks like. So this is my quadratic formula. We do tend to be a little picky about this formula. There's a lot of things you need to be on the lookout for, and I'm going to kind of talk about those things as we go through here. Alright, so I'm going to substitute first. You see I have a negative, and it's times b. In this case, our b is -4, so this is another case where we got to be careful with those signs. Plus or minus the square root. When we square this b, we need a parenthesis. b is -4 squared minus 4 times a times c, and you want to make sure that that root extends over that entire expression. And your division line should also span that entire numerator. And in the bottom we have 2 times a, which is 3. Alright, so now we just need to start simplifying and cleaning it up. So -1 times -4 gives me a +4. You can enter what's underneath here in the calculator. I did it in 2 steps just to kind of be a little careful with my signs. That -4 squared inside the parenthesis is going to give me a 16. And then -4 times 3 times -2 is going to give me a +24. Over that 2 times 3 is 6. So if I add 16 and 24, I get 40 underneath the radical over 6. And of course, we can't forget the rules that we have already learned in previous material. The square root of 40 can be broken down, right? We can write this as 4 times 10 over 6. And then we know that the square root of 4 is 2, so we get 2 root 10 over 6. And then if you notice this, all of the terms in this expression are even, so we know that we're going to have a common factor. I would prefer if you do this next step the way that I'm showing it. In the numerator, I have a 4 and a 2, and they have a common factor of 2, so I'm going to factor that out, and that will leave me with 2 plus or minus the square root of 10 over 6. And then we can cancel these two, leaving me with x is equal to 2 plus or minus the square root of 10 for my answers. Over 3. So we could ask for these answers in one of 2 ways. If I ask you for the exact answer, this is what I'm looking for. If I asked you for an approximate answer, that would mean I would want you to separate the 2 cases and enter it into the calculator and get an approximation. Alright, so let's see what we would get. If I enter 2 plus square root of 10 on top divided by 3, I got 1.72. And if I enter 2 minus the square root of 10 all over 3, I got, for this one, negative 0.39, and that was rounding, okay? So exact answer, we would leave the answer with the root, and approximate, we would enter it into the calculator, and I would have to tell you how many decimal places that I was looking for you to know, okay? All right, let's look at another one. So for number 2, if we start back with our list, first we want to know if our equation is in standard form. And of course, this one is not. So I need to be equal to 0 to be in standard form. So we'd get negative 6 minus x squared minus 5x equals 0. And of course, then we're going to have to rearrange. Standard form has them in descending order. So we'll have negative x squared minus 5x minus 6 equals 0. So now it's in standard form. So we can read off our A, B, and C. So A in this case is negative 1, B is negative 5, and C is negative 6. And of course from there, we're going to plug it into the quadratic formula. Alright, so we get negative. We're going to substitute B, which is a negative 5. Under my root, I need to square B. Of course, it needs to be in a parentheses. Minus 4 times A is negative 1 times C is negative 6. And make sure you extend the root. All over 2 times A, which is negative 1. Alright, so then we can start cleaning it up. A negative 1 times negative 5 is 5. If I square negative 25, if I square negative 5, I get 25. And then negative 4 times negative 1 times negative 6 is negative 24. Over 2 times negative 1 is negative 2. So if I simplify under the radical, 25 minus 24 is 1. And this time, I didn't get a root like square root of 10. I got a perfect square. So we know that the square root of 1 is 1. So this one, we're actually going to get rational or integer answers. So we can split this into 5 plus 1 over negative 2, or 5 minus 1 over negative 2. So this one would be 6 over negative 2 is negative 3. And this one would be 4 over negative 2 is negative 2. Now, just a note about this. If there is a perfect square under the radical when you do this process, that means the original equation was factorable. We'll talk about that a little more in a little bit. But of course, this question said for us to solve it by using the quadratic formula. So as usual, when we have more than one method, be careful if we're asking for a specific one.